Now we're into the most important part of this lesson, knowing how to find the inverse of a function and knowing how to graph them. So I'm introducing 4 steps and 3 examples. Example 5, find the inverse function of f of x is equal to 3x minus 1. So looking at the 4 steps, step 1 is replace f of x with y. So we're going to do y is equal to 3x minus 1. Then interchange x and y. So y will become x and x will become y. Now we solve for y. So to get y by itself, I need to move the negative 1 over to the other side. So add 1. Over here, I have x plus 1 is equal to 3y. And then finally divide both sides by 3. That will help us get y by itself. And then step 4, replace y with the notation for inverse function. So this will be x plus 1 over 3 is equal to y, which is f negative 1 of x, or the inverse function of f. So this is the final function. So this is step 1, step 2, step 3, and step 4. Example 6. Let's do it again with the 4 steps. Step 1, replace f of x with y. So we have y is equal to 3 minus x over x plus 3. Step 2, we want to interchange x and y. So y becomes x and x becomes y. Step 3, we want to solve for y. So I see that y appears in 2 different places here. So first I'm going to clear the denominator by doing cross multiplication. You can make x over 1, do cross multiplication. So we have x times y plus 3 is equal to 3 minus y. 3 minus y times 1, which is 3 minus y. Now I'm going to remove the parenthesis just so I can get this y out of there. So I have xy plus 3x is equal to 3 minus y. So I noticed that y right now are on 2 different sides of the equation. I want to group them into one single side and then everything else on the other side. So I'm going to move this negative y over by adding y to both sides. So it's going to look like this. xy plus y and then plus 3x is equal to 3 because negative y and positive y here cancel. And then I want to move this 3x over to the other side. So that's going to be 3 minus 3x. Okay, so to get y by itself, first I am going to need to factor out y. So then I have x plus 1 here. Now this looks good because y now only appears in one place where we can easily isolate it by dividing both sides by x plus 1. So we end up with y is equal to 3 minus 3x over x plus 1. And the final step, so step 4 is just to replace that y with the inverse function notation. So that's 3 minus 3x over x plus 1. And so that's the final answer. Last example. This time we have f of x is equal to square root of x minus 1. Find the inverse function. So step 1, we're going to replace f of x with y. Step 2, interchange x and y. So x is equal to square root of y minus 1. Okay, so y is currently trapped inside of a square root. To let it come out, I'm going to square both sides to break that square root. So on this side, I'll have x squared is equal to square root and the square should cancel. So you have y minus 1 here. And then to get y by itself, I just have to add 1 to both sides. So y is equal to x squared plus 1. Okay, so that's step 3. I got y by itself. And then step 4, I just replace y with f of negative 1, or f negative 1 of x, the inverse function of x, which is x squared plus 1. So we have a slight problem. This function that we just found is a parabola, which means it's not a one-to-one function because it doesn't pass the horizontal line test. So perhaps with the parabola, if we just accept half of the parabola, it might work. So how do we know which half to accept? So that will actually bring us to part B. So we're gonna finish this one in just a minute here. So part B, find the domain and range for both f of x and the inverse of f. I mentioned earlier that the domain of f must be the range of this inverse function, and the range of f must be the domain for its inverse. So if I were to find the domain of f of x is defined by square root of x minus 1. I know that x minus 1 must have the condition being greater than or equal to 0 because we don't want the radicand to be negative. So x must be greater than or equal to 1. So that will be the domain for f of x. We can automatically conclude that that means the range for the inverse function of f must be also greater than or equal to 1, but instead of x, this time we have y, because remember we interchange x and y. Now, the range for f of x, so the range for f of x, we know that it is a square root. And whenever you take the square root of a number, that will always result in something that is greater than or equal to 0. So therefore, y is greater than or equal to 0. So we can conclude that the domain for the inverse function must be greater than or equal to 0 as well, but this time we're going to put x in there because x and y interchanged. So with that said, this function must have the domain that x is greater than or equal to 0. So when you draw a parabola for this function, this looks like a function that has been shifted up 1 unit. So it looks something like this. Okay, with the condition that x has to be greater than or equal to 0, we technically only accept this half of the parabola, which makes it a one-to-one function because it would pass the horizontal line test. Okay, so we're going to go into more detail with the graph in part C here. In this one, we have to graph both functions. So here's a fact. The graphs of f of x and its inverse f negative 1 of x are symmetric over the line y is equal to x. So I already have this y is equal to x line graphed. Basically, just y are the same as x. So if x is 1, y is 1, x is 2, y is 2. It's a very easy line to graph. So first, the f of x function is square root of x minus 1. So we can make a table. So x could be 1, then 1 minus 1 is 0. Square root of 1 minus 1, square root of 0 gives you 0. Let's say x could be 2, then y will be square root of 2 minus 1, which gives you 1. And let's say x could also be 5. So then square root of 5 minus 1, that's square root of 4, which gives you 2. Let's plot those points. So 1, 0, 2, 1, 5, 2. So it's this line, this curve right here. This is the graph of square root of x minus 1, which is the f of x function. Now we're going to graph the inverse function. So f negative 1 of x is x squared plus 1. You could create a separate table, or you can also just reverse these order pairs. So the first order pair is 1, 0. So then the order pair over here will be 0, 1. Second one is 2, 1. So this will be 1, 2. Third one is 5, 2. So this will be 2, 5. So we can plot those points, 0, 1, 1, 2, and 2, 5. So that will be here. and connect those dots, then that gives us the graph for the inverse function, which is x squared plus 1 with the condition that x has to be greater than or equal to 0. That's why you don't see the full parabola. But if you observe these two graphs, you will see that one is the reflection of the other over the line y is equal to x.